Okay, ladies and gentlemen, let's take a look at surface area of a prism. Now, we can always draw prisms by drawing whatever shape we need for the base, then moving up at 90-degree angles from those corners. That would make, of course, a right prism, and a right prism, of course, meaning you have a right angle there at the base. And the problem with this is it's only as good as your artwork. Now, we do need to talk about a few things. With the prism, this is an edge. This edge is where two faces come together. So a face would be on this side, a face would be on the top. So for example, I have a face, a face, a face, a face, a face, and a face. So a cube has 6 faces here. Now the edge would just be this part right here where these two faces come together versus a vertex, which makes sense where it's a single point where various edges come together or various faces meet, 3 or more faces meet. So you have a vertex. Now, that's important to know because vertex has all sorts of angles. In our case, for a right prism, it's going to be a right angle. Now, bases. In a cube, it doesn't matter whether I set it like this or like this or like this because all of the faces are congruent. So if all the faces are congruent, it makes no difference which one is the base. Likewise, I have this pyramid, which happens to be an equilateral pyramid. And if I had this and I drew it out, I could set it on any face I wanted and it wouldn't make a difference. However, if I have something like this becomes more problematic because obviously this shape here is not the same as top or bottom. So the bases have to match. Bases in a prism are both parallel and congruent. Parallel and congruent. So those would be the bases. Now, for surface area, what we're going to want to do is we're going to add up all these sides. Well, to add up all these sides, you say, well, can't I just take 1, 2, 3, 4, 5, 6 squares? Well, in the case of a cube, you would be correct. Technically, for a cube, you could find the area of one base. So here we go. Let's do a little trace. Here we go, here we go. And because I cut these, I know that this is 3/4 of an inch by 3/4 of an inch. And so I could say 3/4 times 3/4, 0.75 times 0.75. There you go. And that is 0.56, but there would be, of course, 6 faces, so I multiply by 6, and the surface area is going to be 3.375. Now, that's nice if this were a cube, but the problem is, what happens when it's not a cube? In this case, let's take 2 of these guys, and let's stack them up. So here we go. We have stacked them up. In this case, this face may happen to be the same as this face, may happen to be the same as this face and this face. But this face down here is obviously very different than that. Whereas here we have 1 square unit. Here, this is clearly made of 2 square units. So I have actually 1, 2, 3, 4 sides that are 2 square units and 2 sides that are 1 square unit. It's easy enough if I have to count them up. But if I have a more complex shape, something in this ballpark, now I have all sorts of different things going on here. In this case, I'm going to have a face with a 4 units, a face with 6 units, another face with 6, and another face with 6. And if I made it something like this, now they're all different. I have one face with 3, one face with 6, another face with 3, another face with 6, a face with 2, and a face with 2. And that's all fine and dandy if they label them out for you. But what I'm going to need is I'm going to need something a little bit different. So in fact, let's take a look here, and I am going to do a little tracing. So in this case, we know we have a face this big. we move it around, we know we have a face that is this big. We also know now that we have a face that's this big, and we have a face that is this big. So what I can do is I can unroll it in essence. And in this case, it's going to be 2 by 3, 1 by 3, 2 by 3, 1 by 3. Well, that works out nicely, but here's the thing. Those are only the sides. We haven't done the bottom of the top. So if I do this, I have to put a face down here that would be the bottom. And I would flip it over, and I would do the top. And in this case, I have 1 by 2 and 1 by 2. So if I put all these faces together, then and only then do I have all of the surface of that shape right there. So I could either go 2 length by widths, so length by width, so length by width, length by width. I would also have 2 length by height, and there's one there and one there, so there's 2 of them, plus 2 width times height, width 1, height 3. So 2 width times height. Well, that's all nice, except for the fact I have a 2 in each place. Okay, I have a 2 in each place. I also have heights in these two. So I could say 2 length times width plus, take a 2 out, and that leaves length times height plus width times height. Okay, and so we put all these things together, and the short version of this is the surface area is going to be 2 bases, because what is the base of a rectangular prism? The base would be length times width. So 2 bases plus 2 lengths plus 2 widths. Well, a width, a length, a width, a width, a length. What have I actually done but gone all the way around this figure? And so what do I take with the distance all the way around a figure? Here, 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 here. That's going to be perimeter, and they're always going to be multiplied by height. So 2b plus ph, 2b plus ph. Now, in this case, that's our general form. For our specific one, we have surface area would equal 2 length times width plus perimeter times height. So I have 2 times the length, which is 2, times the width, which is 1, plus perimeter. Perimeter is going to be 2 plus 1 plus 2 plus 1. So that's going to be 6 times height, which is 3. So 2 times 2 times 1 is 4, plus 6 times 3 is 18. Okay, and so I get a total of 22 units squared. Now you'll notice these are units squared because it's something times something, units times units in each case, and then I add up unit squared plus unit squared plus unit squared, so that it stays unit squared. 22 units squared. Okay, and let's see if we get that. 1, 2, 3, 4, 5, 6. 6 on this side, 6 on this side. So I got 6 plus 6, plus 3 on this side, plus 3 on the other side, plus 2 on the end, plus 2 on the end. So if I put all that together, I get 18, 18 plus 4, 22 units squared. So that is 100% true. So using this formula gives me my total surface area. Now, let's finish our discussion with this guy. If it's an area of a prism, in this case, I have a hexagon. So let's trace my hexagon. There we go. So I now have a perfectly fine hexagon. Now, I'm going to draw it in perspective so that you can see it a little bit more easily. You don't have to be awesome at drawing. okay, but it does help a little bit. So we have this. Now, each side of this shape is, let's see if we can take a look here. I see, for fun and giggles, let's call it 1/2 inch. I think it's slightly below that, but we're going to call it 1/2 inch. Actually, it's probably exactly a 1/2 inch. So we have a 1/2 inch, 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 and a 1/2 inch. So our perimeter is going to be 1, 2, 3, 4, 5, 6 1/2 inches, 3 inches around. Now the height on our nut is, I would like to call it a 1/2 inch, but it's more like 3/8. All right, so the height on the nut is 3/8. So I got a 1/2 inch and I got 3/8. Now what we need to do is, to find this, we need to do 2b plus ph. 2, but the base on this is going to be a little different. Plus perimeter times height. Well, the height we said was 3/8 of an inch. The perimeter we said was 3 inches, so that's good. By the way, this area by itself is called the lateral area, or the lateral surface area. Lateral meaning off to the side, like if the quarterback is running and he pitches off to the side, it's a lateral. So lateral means side, 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 side. So this would be the area of this nut with just the sides, not the top and bottom, lateral area. For total area, I have to add the bases. Now, for a base, nice thing about a hexagon is that you can measure from side to side because they're parallel. And I come up with 5/8. So the distance halfway across, if the whole distance is 5/8, the distance halfway across is 5/16. And we're going to use a special formula, 1/2 AP for the base. So to find the area of this whole deal, the whole base, 1/2 apothem, which is the distance from the center to the right angle with the edge, is 5/16 times perimeter. Well, perimeter we already had was 3. So I have 2, so I have 6, nope, half. So those go away, and I'm left with 15/16 plus 3/8. I get 9/8. Put those together. That would be 15/16 plus, that one's going to be 15/16 plus 18/16, because I have to find common denominators, be 20, 33/16, which would be 2 1/16. So there's 2 1/16 total inches of surface area here. 2 1/16 total inches of surface area here. Now, by the way, that would be if it were solid. The hole in the middle causes me all sorts of problems, because if I actually wanted to find the surface area without the hole, I would have to subtract a circle here and a circle here. But that's kind of above where we're headed. The basic thing is 2b plus pH.